Okay, this is day two of story graphs. Yesterday we we introduced the idea of a story graph, and this is the first time we've looked at graphs that aren't straight lines. It's made up of straight lines, but it's not all one straight line. Okay, and we tried to talk about the idea of a line going up versus being horizontal versus going down and what that means. And we have to look at the labels of the axes, probably to make sense of that, right? And we looked at the difference between a steep line and a less steep line and that kind of thing. And just generally, we're um, observing what that means. You know, they're going faster at a certain time and slower at a certain time, generally speaking, describing a story, a situation that the graph might represent, something like that. We looked at a few different examples. A lot of it was distance and time, but you can do other things as well, obviously. Um, so that was kind of yesterday. Today we're going to be a little bit more careful in not just saying it's slower and faster, but describing it in a little bit more detail. So today is all about using numbers to describe what happens. And this lesson that we're doing is actually an EQAO question from many, many years ago now. So this is pulled straight from EQAO. So it's definitely the kind of thing that we see from time to time. Either a question a lot like this, or something similar has parts of it or something like that. So let's go ahead and give it a try. Emily participates in a 10-kilometer charity walk where the walkers follow a straight path from the start, then return along the same path to the finish. Now, I'm just going to stop there for a second because we don't want to get in, too complicated talking about this. But it's one of the things that's tricky about story graphs is this looks like somebody walking up a hill and then maybe along the top of a hill and then back down a hill. And that's not what's happening, right? So the picture that the graph looks like is not necessarily the story that's being told. You can do a graph of somebody walking up a hill and then back down a hill, but that's not necessarily what these graphs are going to be about when it goes up and then down like this one does. So what does it mean? Well, and what's described here, that somebody starts here, uh, all of the walkers, okay, all of the participants start here. They walk this way to some end point and then turn around and walk back, right? And so it's 5 kilometers both ways, and that's the 10 kilometers total. And that makes sense. And that is kind of what this one looks like, but it wouldn't necessarily have to look like that. That's a simple way. This could be a graph of somebody running in a circle, and they're here at the start, let's say, and they run around and back, right? So they don't necessarily go straight there and back. They actually go around. And for part of that time, they're going away from the start. And then for the other part of the time, they're getting closer to the start in a roundabout way, but they are getting closer to the start. So this could be a race that goes around in a circle and you finish where you started. Lots of races do that. But this one actually happens to be even the more simple version where you are walking the same path there and back and doing it twice, okay? All right, so this graph shows a relationship between Emily's distance from the start and her time. So again, we talked about this. It's always really important to look at the labels of the axes, not only what they say, distance from start, sometimes it's distance from home or distance from school or something like that, but then also sometimes we have units, okay? Now, what's different about today, we saw a lot of stuff like that yesterday. What's different about today is it says, describe each segment of her walk. Include information about distance, time, speed, and direction. So some of these are going to be very straightforward. The direction is going to be a little bit specific, so we're going to talk about that, which will be good. And a little bit of practice calculating speed. We've done this before, but now using units, so it's a little bit different. And you can see this is different today because I'm not actually telling a story. I'm interpreting information from the graph and getting actual measurements from it. Okay. So segment A, some people think it means that spot right there or something, but it means this whole line, okay? So that's line segment A, that's line segment B, this is line segment C. So for line segment A, what's the distance traveled? Well, they started at 0 and they went to 5. So their distance traveled is 5 kilometers. How much time did they take? Started at 0, they got to their end at 40 minutes. So I'm going to put 40, but I also need to put the units, minutes in this case, okay? And I got that from the label there. I can do that for all of them. B, what is the distance traveled? At the beginning of B, they're at 5 kilometers. At the end of B, they're still at 5 kilometers. So how far did they travel? Now it looks like they went 2 squares, but that's the time changing. The distance didn't actually change. So B is 0 kilometers. But their time, some people might say 50 because that's where it ends, but that's not correct because B starts at 40 and goes to 50. So that's a change of 10 minutes. And the reason why it ends at 50 is because of the 40 plus the 10 gives me 50 total if I include A and B, because that's from the very beginning, right? Okay, and then C, the distance traveled. So that's starting at 5 and ending at, okay, this is C, so it starts at 5. And there's the end of C, which ends at 0. And that makes sense because they walked 5 kilometers out and then 5 kilometers back, right? So in this case, that makes sense. So 5 kilometers, how long did they take? Well, they started at 50 and they went to 100. So 50 to 100 is a change of 50 minutes, okay? Before I go any further, let's think about this. They went 5 kilometers in 40 minutes and then 5 kilometers in 50 minutes. So which one was faster, A or C? Going the same distance in a shorter time means you're going faster. So A is faster. If we look at the line, it does look a little bit steeper. You know, it's not super clear, but I think everybody would probably agree it does look a little bit steeper than C. And it makes sense for the real world that you'd be a bit tired on the way back, so it would take you longer. Of course, graphs don't have to match that. It could be a situation where somebody's trying to beat their time, and so they go faster at the end of a race, like anything's possible. But, you know, we could justify that for sure. Not that we have to. Okay, so that was all 3 segments, just thinking about distance and just thinking about time for each of them. What about speed? Well, it tells me right here how it wants speed, kilometers per minute. I've got kilometers, I've got minutes, and the per means divide. This is kilometers divided by minutes, right? It's the same idea. So I do kilometers on top divided by minutes on bottom, and I can do that for every single one of them. Kilometers divided by minutes, kilometers divided by minutes, okay? And now I'm going to need my calculator for this. So 5 divided by 40, and I'm going to want a decimal for this. So that's 0.125. 0 divided by 10, well, that's 0. And 5 divided by 50 is 0.1. And 0.125 is a bigger number. It's kilometers per minute. That's like kilometers per hour. It's just in minutes. So a bigger number means faster. That makes sense. I'm going to add in the units. The nice thing about this question is it kind of told me how it wanted me to calculate it, but I could see some people doing 40 divided by 5 because we like to do bigger numbers divided by smaller numbers, right? And 40 divided by 5 would give me 8, and people might like that better than this strange kind of number. But kilometers per minute is not a normal unit that we're used to working with. So, you know, that's why it's a decimal that we might not expect. So this is faster because it's a bigger number. That's slower. Does this make sense? Yes, 0 kilometers per minute they're not moving there. Their distance isn't changing. At segment B, I guess they're taking a rest before they head back. Sometimes these walks have, a place where you can stop and have something to drink or something like that, right? So direction, what does this mean? What we want to do is we want to state this in terms of the question and what it's talking about. So I have to say the direction is not talking north, south, east, west because we don't know that about this question. Maybe another question gives you that information, probably not, but maybe it does, and you could say that. All we know is the distance here from the start is increasing. So they're getting further away from the start. So we're going to say away from the start. Okay. This one direction is none. And I think it'd be fine to say that. Not moving, I think would be fine to say. No direction, something like that. Okay. I don't think there's any perfect way of saying that as long as you're just saying that they're not moving. So there isn't none. What you don't want to do for EQAO is leave it blank. And thinking that leaving it blank means that there is none, that just looks like you didn't know what to put. So always, always, always put some kind of an answer. Okay, even if it's none or even if you just put a slash through it, that would be better. But write a word, that would be best. Okay. And what about direction for C? Well, their distance from the start is getting smaller and they end up at the start. So where's their direction? They're going towards the start. And this question could easily be about a home, so away from home towards home, or from school, or from a store, away from the store towards the store, anything like that, right? So that's going to be given to you in the question, either in the labels or in the description of the question, or both possibly. And that's what you want to use when you're describing the direction, if that were to come up again on EQAO, okay? So you can see how this is a different kind of question where we had to do a little bit of actual numbers and calculation. We didn't do as much of that yesterday. Yesterday was more about really telling stories and interpreting the steepness of a line or the direction of a line and thinking about how that relates to the axes, the labels of the axes and what they represent, okay? And so you can see there are different kinds of questions, but a lot of this is trying not to get caught up in what the graph looks like, but thinking about the scale of the graph and interpreting the information, reading the information out of the graph that you're given. Or, we did some drawing of graphs as well from given a story. Okay, and that's it for today. We're just doing that one example. So you'll have some work similar to what we did yesterday and another one of these where you have to do some actual numbers and reading of numbers from the graph and from the scale as well.